Hello everyone, sorry this video is in two parts now, and didn't have a distinct ending with the first part of the video. That was because my iPhone kind of ran out of space. Sorry about that, but again, we'll just continue on with the last two examples. This will be a quicker video because we've only got two to go through now. If you haven't seen the first part, please go back and check it. So now I reckon we'll jump onto this one because it's another product rule one. And let's rewrite it out here. So we have x ln x squared plus 1 in brackets, and essentially what we have there, that equals y, of course, because it's a function. But we have an f of x term and a g of x term that we've identified. And from this we're able to differentiate using the product rule. Now you may not call them f of x, g of x, whatever your notation is, you can sort of work out which terms are going to be making up our product rule. And again, if you've been watching my videos a lot, then you're probably accustomed to f of x, g of x, because that's my personal favourite. So now we take the dy over dx, the derivative of this function, and we take the derivative of our f of x term. This is the f prime of x. The f prime of x for this would just be 1, because the derivative of x is just, or a number then x, a coefficient of x, is just going to be that coefficient. And I'm not even going to bother writing that because it's just going to be 1 times by our g of x term when looking at this. So it's up to you. If you want to see that you've got 4 distinct terms there to make sure that you've done the differentiating process correctly, then by all means do that. But for me, I'm just going to jump straight in and write the g of x term as is. And I'm going to use brackets. And then, of course, that's plus the g prime of x, and what we do is we take the derivative of our second term there, and again, it's going to be ln f of x, where f of x is a function, so we take a derivative of what's in the bracket, and the derivative of this would be 2x over x squared plus 1, because that's the derivative. And that's just the f of x here from the rule that we discussed in the previous video. And then lastly, what we do is we take our f of x term, just as is. Nice and simple. So now we can just simplify this a little bit. I mean, making more elegance, of course, is a good thing. So we just have this term, we can't really simplify that down anymore. However, this is x over 1 here, and we can actually expand the bracket. So what we get is we have 2x squared, because that's 2x times x, and I'll make that look like squared, yep. And then we have it all over x squared plus 1, because it's 1 times that, because it's x over 1 that we have in our bracket. So there's our final answer. That's our function differentiated. So hopefully you're able to follow along with that. And hopefully it made a bit of sense as well. So now we're going to go on to the quotient rule, which is slightly different, and just try and make some sense of that particular question. So, this is the last one we have left on our board. Y equals 2 lots of square root x over ln x. And we know our quotient rule is exactly the same as our product rule. We're just smacking a subtract sign in between instead of having a positive plus sign in there, a sum of operation. And of course, one thing to remember, it's all over the, in the denominator we have this term, the g of x term, squared. And again, you should know there's some differential calculus before. These rules all sort of fit together to make a globe of knowledge. So whenever you see a function or a relationship, you'll be able to go, okay, I can use product rule here, or I can use implicit differentiation here. And again, these are just 2 rules to add to your mathematical vocabulary. And I'll be teaching some more rules because we get to look at the e of x soon in my next video, which should be just as much fun, and also incredibly mind-bending, because e of x is its own derivative. But enough of that now. We're talking about ln x, so again, our dy over dx equals, and we get 2 square root x, the derivative of that. What I'll do is I'll just, rewrite this out with exponents to make things a little nicer before I solve. And what we do is we bring the exponent down to the front, so we have half of 2. Half of 2 is obviously going to be 1, so I'm not even going to bother putting that there, but we have x to the half, negative half, because we're subtracting 1 from that exponent. And that's our f prime of x. Then we have that multiplied by our g of x. Our g of x is ln x. And then from there, almost sounds like Linux when I say it sometimes, but we have that, subtract, and we take the g prime of x. Now what's the g prime of ln x? Well, it's right here, it's 1 over x. And then that's multiplied by the f of x, and the f of x is 2 lots of square root x. And I need to do that all over a denominator of ln x raised to the power 2, because I'm using quotient rule. And again, you can simplify here, you can make it nice, get an elegant solution. I'm not going to for the purpose of the video. Obviously I don't want it to be too long because I'm already splitting it in 2 parts, but again, that's how you're able to differentiate it. You just need to use common rules, and you just need to think things through, and you get it nice and clear. So there's a little pure mathematical approach to using some real-world values. ln x, we'll have an e to the x video coming out soon. But again, hopefully you understand these 2 rules, and hopefully understand that k to the x stuff I was talking about in the first part of the video, because again, that can come in handy. You could even have that as a 3rd rule if you wanted to. I mean, it sort of is just, you know, variation of that rule there, but again, if it helps, write it as your own rule. And we'll be looking at some applications of this stuff as well a bit later in the unit, so it should be nice and fun, seeing where ln x fits into the real world. So again, hopefully this helped, and if you have any questions, comments, anything at all, post it in the comments box below on YouTube, and I'll get back to you as soon as I can. So thank you very much for watching. More videos soon.